Alright, let's look at the Laplace transform method. Alright, so our goal is to solve a differential equation. So we start with the differential equation. We want to find its solution. Alright, and sometimes solving the differential equation directly is very difficult. Say here, solving a differential equation is, say, very hard. Right? So what we're going to do is maybe we can turn differential equation into an algebraic equation where there's no derivatives involved. Then solve the algebraic equation, then transfer back to the solution of the differential equation. So that's where Laplace transform comes in. Right? So what we can do is use the Laplace transform to turn differential equation into algebraic equation, right? Then oftentimes algebraic equations are easier to solve. So this is an easy process here. Then you find the solution of algebraic equation instead. Right? Once you have that solution, we're going to take the inverse Laplace transform so that we can get the solution of the original differential equation back. Alright, so it sounds good on paper. Alright, so this is a simple example. Alright, so we have a differential equation x double prime minus x prime minus 6x is equal to 0. Alright, then initial value conditions are given to be x of 0 is 2 and x prime of 0 is negative 1. Alright, so first we're going to just try to apply Laplace transform to the differential equation so that we can find the algebraic equation. Right? So if you take the Laplace transform of the second derivative, we know that we're going to get s squared x of capital X of s, this is the Laplace transform of x, minus s times x of 0 minus x prime of 0, right? And a minus, right? So we're going to take the Laplace transform of x prime, so that's s times capital X of s minus x of 0, right? Then negative 6. Then Laplace transform of x is capital X of s, right? And then Laplace transform of 0 is 0, right? So we put that 0 here. So we take the Laplace transform of both sides and you get this. And we actually know a little bit more about this because here f of x of 0 is 2, so we can plug 2 in there. And here we know that this is going x prime of 0 is negative 1. And here we can also plug in x of 0 is 2. Alright, so what you get is going to be, so this is going to give us, alright, so let's see, we have, let's see, I'm going to collect all the ones with the x of s. So capital X of s. We have here s squared capital X of s. So I'm going to put s squared here. And another one is negative s capital X of s. So you have a minus s. And then we have negative 6 capital X of s. So we have a minus 6 here. Alright, we have that. Then other ones, let's see, you have negative 2s. Or actually not equal. I'm going to just negative 2s. Right, that takes care of this guy. And then you have negative 1, so it's a plus 1. That takes care of this guy. Right? and a negative negative 2, so it's going to be plus 2. Right, and that takes care of this guy. All right, so we can simplify it so that let's see, we're going to have, all right, so I'm going to go ahead and factor this guy out. So you're going to have equals to 0. Forgot to write that. So if you factor this out, I think this is going to be x minus 3. S minus 3, I should say, and s plus 2, capital X of s, and I'm going to actually put everyone on the other side, so negative 2s becomes positive 2s, and plus 3 becomes a minus 3. All right. Then I'm going to try to solve for x of s, so I'm going to just divide through by s minus 3 and s plus 2. Right? So we have x of s is equal to 2s minus 3 over s minus 3 and s plus 2. Right? So we could find the solution, which is capital X of s. This is a solution of the algebraic equation, right? So what we want to do is we want to find the inverse Laplace transform of this solution, which is going to be x of t, right? So first I'm going to do partial fraction decomposition. I'm going to skip the details of the partial fractions because we've done it before. So if you use the partial fractions here, so I'm going to put the partial fractions, then you're going to end up getting 3 over 5, 1 over s minus 3, right, plus, right, and 7 over 5 times 1 over, I'm going to write the s plus 2 as s minus negative 2. All right? So this is capital X of s. Right? So in order to go back to the original x of t, lowercase x of t, what you do is we're going to take the inverse Laplace transform. Right? So inverse Laplace transform capital X of s is lowercase x of t. Right? Then we just have to find the inverse transform. So you have a 3/5 is just a constant. I'm going to put it here. Right? Inverse Laplace transform of this guy is e to the 3t and plus 7 over 5. And the inverse Laplace transform 1 over s minus negative 2 would be e to the negative 2t. Right? So you can see that we already found the solution of the initial value problem there. Right? So this is how the Laplace transform method work. So you have a differential equation, apply Laplace transform to turn it into algebraic equation. Then solve the algebraic equation, and the solution is gonna look like capital X of s, right? But what you're looking for is lowercase x of t, so we can apply the inverse Laplace transform to get the solution, which is x of t, and which we found it here. All right, that's it. I hope that this was clear.